Now, let me show you how to set up a linear programming model in the Excel spreadsheet for the max and the multi-max production problem. And as you can see, I have some different color shaded here. I just want to point out those blue shaded cells which contains the input parameters. Those are the information we know from the problem setting. And on top of that, we know we need to first figure out the changing cells. So we have two changing cells, one for the number produced for max, the other is number produced for multi-max. So I put it here, so product mix plan, I shaded these changing cells in red. And then we need to set up the objective. Okay, this objective is total profit. So I need to calculate the total profit based on how many are produced for max and how many are produced for multi-max. Of course, I also need to use the unit price. Okay, so what I'm going to do is I'm going to use a function called sum product. Okay, so because I want number of the max times with the max unit price plus number of the multi-max times multi-max unit price. So very useful Excel tool called sum product function. It can help us to quickly do such calculation. Okay, so it requires two parameters. They have the same size of the range, so they will multiply each other and then sum them together. So this is a sum product. So right now, since I didn't put any units for max and multi-max, so total profit is 0. How about let me try to put one for the multi-max and another one for the multi-max. So it's updated. So you can see it's 400 plus 800. Okay, so this is an objective function done. Then we need to configure the constraints. So we have two resource-driven constraints. So we available is testing is 5,000 hours. This must be greater and equal to what is used according to my changing cells. So again, I can use the sum product function here. So sum product, this is the product mix, the changing cells. So times with this capacity using requirement with respect to the testing. Okay, so that is what I'm got based on one max and one multi-max. Now for the assembly, how many is used? Okay, we can calculate the same way per sum product using the changing cell, but this time we need to use the assembly capacity hours. Okay, so this is if you produce one max and one multi-max, then your total will use 4 hours of assembly. So we know assemblies available is 3,000. So the total usage for the assembly from the two products cannot be larger than the 3,000. Okay, now to this point, we have set up the spreadsheet, and then we are going to go to, remember there is a non-negative constraints, which is a boundary constraint requires the both product number for the max and the multi-max must be non-negative. We are going to specify that condition in the solver. So what is the solver? Solver is the one help people to find out the optimal solutions or find out the equation solutions to some equations. So solver is in the data ribbon, and you will see at the very end there is an analysis section, and the solver is one of the buttons here. But if this is the first time for you to use the solver, you may not necessarily find the solver in this place. So you need to ask Excel to add in this function. So how to add in solver? Then what you need to do is you go to File, then go to Option. There is Add-ins. Okay, so Manage Excel Add-ins. You click a Go button. Then there is a kind of add-in available. So make sure you check the solver add-in. Then you click OK. Then you will see the solver appear in the data ribbon. All right, now let's call out the solver. You see how to configure the solver. First thing in the solver is set objective. So our objective is calculated in this green cell. So we want to maximize it. Okay, objective done. Then second thing is the changing variable cells. So you need to refer to your spreadsheet setup to indicate, okay, my changing cells are put in those two red cells. Then it's done. Then next we go to add in the constraints. So we click Add button. So cell reference. Okay, cell reference is what we have calculated based on the changing cells. So this one, okay, need to less than or equal to testing. This one need to equal and less equal to. Then go to constraint cell, a constraint place. Then refer to the available testing hours. Then you click Add. Next, for assembly, so consumed assembly hours must less than or equal to 3,000. So this blue cells. Then you click OK. Now you will see two constraints. So capacity-driven constraint is resource-driven constraints put in. Now, for the non-negative boundary constraint, look here. So by default, you have this box checked. So this means make unconstrained variables non-negative. So max and max will going to be non-negative. All right, now constraints finished. Finally, the most important thing, you need to tell Excel this is a linear programming. So this is done by select an appropriate solving method. So GRG, this is for nonlinear. You need to go with this simplex LP. Okay, now everything set up in the solver. Click Solve button. All right, so we got the solution. So suppose once you Excel find the solution, you will see this pop up. He will asking you whether to keep solver solutions. I click on OK. Then that is the solution, and you will find that is exactly what we got from our graphic approach.